Alright, dilations on the coordinate plane. We played around with this in class, so let's get some of the details down. So, first thing, how do you do a dilation on the coordinate plane? Well, it's pretty easy. You take each of your coordinates from your image. Say we have 1, 2, 3, and you multiply them by your scale factor, which is often given by the letter K. So, you can see if we look at how each one has been changed here. In this case, we can see that the scale factor is 2 because each coordinate has been doubled from the pre-image to the image. So, quick example. We have triangle ABC. We're going to dilate from the origin, and we're going to use the scale factor of 2. We have our points. Let me plot those real quick, so I'm going to pause. Okay, there's my triangle. I'm going to dilate it by a scale factor of 2, so I'm going to double everything. Let's start with A. -2, -2 becomes -4, -4. Then go to B. 1, -1 becomes 2, -2. So let's go ahead and connect them so I don't forget. And C, 0, 2 becomes 0, 4. 0 times 0 is 0. So, there's my dilation. If you happen to have a negative scale factor, you get both a dilation and a rotation. Get a dilation and a rotation. So, let's take a look. Same example, and let me pause to plot it. Alright, so when I do a negative dilation, I'm going to multiply everything by -3. So we're going to get +6 for A. We're going to get +3, -3 for B. And we're going to get 0, -6 for C. Oh. Alright, so let's look at an example of a negative scale factor. So, I'm going to pause while I plot this. Alright, so -2, -2, sorry my point's a little off, becomes +6, +6. 1, -1 becomes -3, +3. So -3, +3. And then 0, 2 becomes 0, -6. Connect those. Good to have a ruler when you do this. So it's both flipped and gotten bigger. Something that I haven't mentioned yet is that if you have a fractional scale factor, it gets smaller. Might need to drop that down. Something that you should know here is that the sides of the dilated image will be parallel to the pre-image. I'm going to show you a quick proof. If we have the slope formula, we have y2 minus y1 over x2 minus x1. Let's say we have a scale factor of k. So that means I'm going to multiply everything. I'm going to have ky2 minus ky1 all over kx2 minus kx1. So when I rewrite this by factoring out, scale factor, factoring. I'm going to factor out a k here, factor out a k here, and oh my gosh, those k's cancel out, and we're left with the original slope formula. So multiplying those values by the same number doesn't affect the slope. The sides will be parallel. Alright, so this one's a bit of a doozy here. If it's not centered at 0, 0, the best way to go about this is to translate so that the center is back at 0, 0, then dilate, and then you're going to undo the translation. So here's a quick example of that. Okay, so first things first, we're going to translate back to 0, 0. So to get my center of dilation, which is this yellow point here, back to 0, 0, I need to go up 3 over 2, up 3 left 2. So I'm going to do that to each point, then dilate, then undo it. So here it is translated, up 3 over 2. Here it is after I dilated the regged figure by a factor of 2. Now I'm going to shift it back so that it's the actual dilation of the green one. The red and blue have just been in between steps. So I'm going to undo the translation. I'm going to go down 3, right 2. Okay, so take a look at the orange figure here. Here's A prime, here's B prime, here's C prime. I know I've got a lot going on. I know orange is the correct one because I could trace a line through each point and they would line up back with our center of dilation. That's one of the things we said about dilations, is that they have to all line up. Alright, it's time to write your summary. Some things to consider are what happens to the coordinates, what happens if the scale factor is negative or a fraction. I mentioned that too. What's true about the sides, and a little bit about how you dilate if it's not centered at 0, 0.